Now we want to move to our next speaker, Dr. Hamad, facing some problem. Now I invited Dr. Muhammad Muzammil Azad. He's an assistant professor at CEMA NUST, Pakistan. Sir, are you here? Served as a postdoctoral researcher and later as an assistant professor in the Department of Mechanical Robotics and Energy Engineering at Dongguk University, Seoul, South Korea. He earned his PhD in Mechanical Engineering from Dongguk University in February 2025. We warmly welcome Dr. Muhammad Muzammil Azad. Sir, over to you. Dr. Muhammad Muzammil Azad, sir. After a minute, he is joining. In digital sessions, we are facing some problems like internet connections and elsewhere. Participants, please wait. Soon he will join us.
Am I audible now?
Dr. Muhammad Muzammil.
Yes. Am I audible now? Okay.
Yes, sir.
So first of all, I would like to thank the conference management for inviting me for this session. So I am going to share my presentation. So I hope that the presentation is visible now. Okay. Okay, so I will start the presentation. Okay, so in this conference, I think the audience is from a diverse background, and also the conference is related to the science and technology field. So I wanted to basically introduce some concepts of how we can implement AI in engineering. So although I have a background of mechanical engineering, so there will be some stuff that is related to the pure mechanical background, but still I think most of the audience, I think they are well familiar with science and technology, so they can grasp some concept from these slides and they can also implement them in their own fields. So again, I would first like to thank the conference management for inviting me for this session, and I am really happy to be part of this conference. So let's start with this presentation. So to briefly introduce myself, I am Dr. Mohammad Muzammil Azad, and I am currently assistant professor at NUST University EME campus. And this is one of the most prestigious institute in Pakistan related to this science and technology field. So these are the main contents of this presentation. So first I will introduce my educational background, my professional experience, and then I will introduce some my research interest and my achievements as well. So related to my educational background, so I did my PhD I completed it in the last year, February 2025, and I did my PhD in mechanical engineering from Dongguk University, South Korea. And I stayed in Korea for about 5 years, and during first 4 years I completed my PhD, and then I did 1 year job there as postdoc and also as a assistant professor. And the topic of my thesis there was the deep learning based advanced data-driven methods for prognostics and health management of laminated composite structures. Before that, I did my bachelor's and master's from here in Pakistan, and it was from the same institute, High Tech University. And I did my master's from 2018 to 2021, and before that, for 4 years, I did my bachelor's there. And during my stay at High Tech University, I learned a lot of things, and I would here, I think there is a good platform to thank and acknowledge the people that support you or that are good mentors of you during your career. So here I would like to thank Dr. 𝒖𝒑𝒊𝒄𝒏. He is currently associate professor at ComSearch University. So he basically helped me a lot in developing my career, early career when I was master student. So I worked uh, under his supervision during my masters. So he has a very huge role in the career development that I have accomplished till now in the academia. So next, about my professional experience. So as I mentioned that I am currently assistant professor at NUST College of Electrical and Mechanical Engineering. So I joined here in January 2026, and currently I am serving there as an assistant professor in Department of Mechanical Engineering. So because I think the audience is from multiple countries, so I would like to basically briefly introduce about the how this university NUST. So NUST is basically National University of Sciences and Technology, and it's located in Islamabad. And these are the rankings of the university based on different departments. So the blue one is all across the world. So this is based on the QS world ranking, and this green one is the ranking in Pakistan. So here we can see that in most of the departments, NUST is basically the #1 institute currently in Pakistan, and basically I belong to this engineering and technology sector. So in this category, NUST is the #1 institute in Pakistan, and it is ranked 132 this category. So the location of NUST, it is located in the beautiful city of Islamabad. So this is also the capital of Pakistan, and it is worth visiting, I guess. And the campus I am in, it is located near to Islamabad. It is in Rawalpindi. So about my professional experience before joining NUST, I was also assistant professor at Dongguk University, same university where I did my PhD, and I served there for about 1 semester. And during that time, I co-supervised 3 master students, and before that, for 1 semester, I did some postdoc research, and during that, I taught some subject related to machine learning and engineering application. And this is some prior experience that relates to some like teaching assistantship and the graduate research assistantship that I did during my earlier career as a researcher. So moving on to the research interest. So as you guys must be familiar with the AI, so I will integrate my research with AI, and I would like to explain how AI can basically be adopted in the science and technology field. So in the mechanical industry or other industries as well related to science and technology, the maintenance is the critical component of all of these industries that are related to especially the science and technology field. So the maintenance strategy, we know that uh, it has some evolution over the times. So previously, maybe in the last century, the major type of maintenance was the corrective maintenance. So in the corrective maintenance, whenever a part
Excuse me,
failed,
sir.
yeah, yeah,
Excuse me, sir. Sir, please
yeah,
allow your voice. Your
allow
voice
your
is
voice.
not clear.
Okay, I will. So is it clear now? Is it clear, the voice?
Yes, sir.
Is it okay? Okay, so I was talking about the maintenance industry. So earlier in the last century, the main type of maintenance was basically whenever a part failed, so it was basically replaced. So this sort of maintenance was called as the corrective maintenance. Later on, they thought that it is not good because whenever a part fails, it basically means that the whole system will be in the shutdown phase. So to overcome that, later they developed some interval-based maintenance. So what interval-based maintenance is basically that after some time, maybe if we talk about an object, if its life is 1 year, so maybe they try to check the part after every 3 months or 4 months, and they check what is the current situation of the part, and then they try to replace it. But recently, in last 1 or 2 decades, the entire shift has been towards the condition-based maintenance. So what it means that it is we need to replace the part only when needed. So it means that we are analyzing the objects or the system again and again in real time, and whenever we require that the system is not operating under the desired conditions, then we try to replace that part, and this is called as the proactive maintenance, and it is a recent trend in most of the industries that they are using this, either this condition based maintenance or the predictive maintenance. So these two terms are correlated with each other, and between these two terms they are related to this prognostics and health management. So this prognostics and health management, which is also referred to as PHM, it is a key technology to accomplish this CBM, the condition-based maintenance, and also the PDM, which is the predictive based maintenance. So moving on to how we can perform this PHM in different fields. So first we will see what are the different types of maintenance or PHM based techniques that we can accomplish. So there are two major type of techniques that can be used. The first one is the physics based maintenance and the second one is the AI based approach. So in physics based approach, what happens is that we design the system based on some mathematical formulation. So for example, if we have some structure, so that structure is based on some physical principles. So like we have the Newton's law of motion and some other laws. So based on those laws, we govern the physics of the system, and we incorporate this physics into the system to basically identify when the system is requiring the maintenance. The second form of maintenance that is basically very much hot topic in recent years is the AI based approaches. So in AI based approaches, what we do, we install some sensors onto the structure or any system. So these sensors basically provide some data related to the health condition of the system. So using the sensor data, we basically define some time domain and frequency domain features, and these features are basically then provide us the information if the system is operating under the faulty condition or under the normal condition. And we can also then predict the health of the system based on these signals that we attain from different sensors. So here we can see that example of the features are that uh, they can be of different form, and based on these features we can identify the classification index, where either the system is operating under the normal conditions or it has some caution, or there is some danger of the failure of the system. So then based on these different parameters, we identify the health state of the system. So this health state can be originally it is 100% when the system is very new, and later on it degrades and it can be 90%, 80%, 70%. So we can, based on the application, we can decide a threshold, and whenever this health state is below that threshold, so it means that the system has started to fail. So this was the basic approach how we can adopt AI to this PHM regime. So this sort of approach, it can be adopted in any field related to science and technology and to the other fields as well that are related to some non-technical fields as well. So moving on to these domain knowledge, that is if the system is AI and how we can implement the PHM in that approach. So we can relate these two things together. So I will try to uh, show this video, and this will basically improve the clarity of the students for the. So for example, we have a bearing, and in this case we have a normal bearing and some other bearings as well. So whenever we have some data from these bearings, this can be in the form of vibration data, some acoustic data, or some other sensors that we have installed to these bearing systems. So based on this, we can, these AI algorithms, they can identify some values, or we call generally in AI terms, we call them as the feature of these bearings. So these bearings, when they perform, they are operating, we have some different sort of features for different bearings. And in this, we can see that this blue dots, they represent the healthy features. So these are for these normal bearing. And as this bearing is operational for hundreds or thousands of cycles, it starts to get degraded. So when it starts to degrade, it means that it is moving towards this red zone. So we define these lines using the AI algorithms that when the system is operating under the normal conditions, when we have a warning for the system that it is not 100% operational, and when we decide the threshold value, that the AI algorithm has decided this threshold value, that after this threshold value the system has a warning or a fault that it will start to fail, or it is about to fail. So based on this, we define the AI algorithm which basically identifies the fault in these systems. So generally when we are solving, when we are seeing the getting the signal from a bearing, so we call it as a time domain because we obtain the signal based on different times like 5 seconds, 10 seconds, 15 seconds. So based on this, we can implement these strategies in the real time as well. So AI can be implemented in real time to identify the faults in these systems. So here we have a real time data, and for each data, it is plotting some features here. So we see that as the time passes, these features are moving toward the warning zone, and then we can see that it will start in the damage zone as well. And in the signals in the time domain, we can also observe that there are some messy signals now. So it means that the bearing is has some fault, so it is not operating under the normal conditions. So this was a basic example how basically activated in the real time in the modern industries. So in these terms, as I presented previously, that we had two types of things. First is the physics informed or the domain knowledge, and the second one is the AI. So this was the difference between how we can convert this domain knowledge from different sensors into these AI-based methodology, where we can visualize if the system is operating under the normal conditions or it has some fault in its operation. So next we have some steps to accomplish the PHM procedure. So the first step is the target selection. So here we can see different industries. So basically this PHM, it can be implemented into any industries that require the maintenance. So we can have some industrial robots, we can have some car signals, we can have some signals from the wind farm. So it has a lot of applications, so we can name them all here. We will be short of our slides. But moving on to next step, so then we have the sensor data acquisition. So in this phase, we basically identify first the what kind of sensor we require, and then we install these sensors on these our target objects, and then we try to get the sensor data, and then we analyze the sensor data using some AI algorithms. So before analyzing, we extract some features. So all of the sensors we install, we can basically identify the most suitable feature for that application, and using those features, we can identify some health state, what are the safe conditions for this system, and what can be the failure condition for these systems. And in the last step, we basically use these features and we train some AI algorithms. These can be some machine learning algorithms like SVM, or they can also be some deep learning algorithms where we have a lot of layers, like very deep architecture with a lot of layers. And these layers are basically used to identify or learn the patterns from these different sort of applications. And based on these, we basically try with different models, and then we identify which model is performing the best, and then we basically implement the best model in the actual real world industrial scenarios. So what it will do, it will basically provide us the either in the form of classification if the system is operating normal or it is failing, or it can also provide us with some value, like if the system has operated for 1000 cycles, so it means that it will have some remaining life. So it can basically provide us with the value that this system has a remaining life of 5000 cycles, 10,000 cycles, and so on. So this is the basic process of how we can implement the PHM strategies in this different domains when we have different sort of industries. So next, during my PhD research, my main interest was related to PHM. So I implemented some PHM strategies on different applications, and the major application that I worked on was the composite structures. So these composite structures, they provide basically better properties compared to the metallic structures. So that's why they are a very hot topic, and they are commonly used in the aircrafts to make the structures very lightweight. So what I did, I developed four algorithms. So based on these four algorithms, I contributed to the current challenges and tried to overcome those challenges. So the first challenge in these AI is to basically the data from the actual structure is very limited, especially when we discuss about the faulty conditions. Under the faulty condition, we cannot operate a machine for a longer, because there are some consequences of if you operate the machine under the faulty condition, then there can be some consequences that we want to avoid. So it means that we have very limited data under the faulty conditions. So in this case, I performed some autonomous multi-class data augmentation to increase the size of the data set, and I also incorporated some transfer learning approaches to overcome this limited data issue. The third one was because the actual signals in the industry, we see that there are a lot of machines that are installed in series. So all of the machine has some noise that can be a part of the sensors. So to reduce that noise, I developed a noise robust damage detection model, and it used some advanced signal processing tools to accomplish that task. And in the AI domain, generally the AI models are black box in nature. It means that we cannot have some physics, what is the physics behind the object, what are the physics behind the predictions that the AI model is making. So I tried to make them a little explainable using some approach, and this is a sort of model that we called as the explainable deep learning model. So for this PHM approach, I implemented it on different applications. The first one I mentioned is related to the composite structure domain. The second one I implemented on a power plant as well. And during my PhD, I worked on different other projects related to science and technology that include like the smart factory project and the designing and optimization of medical waste shredding system and some improvement of mechanical and flame retardant properties for these different sort of composites. So these are different projects that I did during my PhD. And I have different collaborations that are going on, and most of them are again related to the PHM domain. So we are currently working, I am collaborating with my lab and another university in South Korea that is related to LAM-wave based PHM of laminated composite. So this is another approach that we can use to perform the PHM of different structures. And with China, I am collaborating with two universities, and this is also related to the remaining useful life prediction and uncertainty in the PHM. And these are some other collaborations that I have currently in Pakistan, Canada, and USA, and most of them are related to how we can integrate the AI into the engineering sector. So for future work, my main goal is to implement the same PHM strategies into various other fields. So my current focus was on these composite structures during my PhD. So from now onwards, I am planning to extend my research from composite structures to maybe the industrial robots. So in the modern industries, we see that there are most of the operations they are performed by the robots. So I want to check how we can implement the PHM on the industrial robots. So recently have been an increased trend in the use of the renewable energies, and we can basically perform the PHM of these energy systems, and we can in these energy systems we can have some solar panels or some windmills that can be basically analyzed using these AI based PHM techniques. And the fourth one, recently in Pakistan as well, and throughout the world, we have seen the use of electric vehicles a lot and the electric bikes. So we can basically implement these PHM techniques uh, on those systems as well, and we can analyze the battery life. We can analyze how the battery is performing, is the battery is heating or not. So based on that, because in EVs the main concern is that the batteries basically explode when the temperature reaches uh, basically a high value. So in Pakistan, like we have a very high temperatures in summer, so it means that is a high chance of explosion of the batteries. So we can implement the PHM techniques. So these PHM techniques can then predict and tell us in advance that when the temperature is exceeding our desired limit, so we need to cool down the battery or we need to replace the battery. So these sort of applications I want to work on in the near future. So moving on to my achievements. So till now, I have around 45 journal publications, and these are basically some journals that I have published in. And among those 45 publications, I have around 21 publications that are in top 10 journal papers. And currently, I have a citation score of around 150. And I have also published numerous conference papers, around 55, and I have patents that I published when I was during my PhD when I was in Korea. And these are some awards. So I got the best thesis award from Korean Society of Mechanical Engineering, and uh, I got some other awards from different conferences based on my PhD work, such as the Best Poster Award, two Best Poster Awards, and some Best Presentation Award from different conferences. So thank you for the attention. I am open to the question from the audience. So if anyone has any questions, so they can please ask. Use AI to test batteries performance and lifetime for mechanical work. Yes, Imtisal, we can implement AI to test the batteries. So the basic approach for AI is that we need to install some sensors to the system. So those sensors we can install to any system. It can be battery, it can be some bearing, it can be any other system. So since you are asking for batteries, so yes, we can implement AI to test battery performance and lifetime. and we can also identify what is the remaining useful life of the battery, and we can also relate it with some mechanical performance as well. So to mention briefly, there is some public data sets that are available. One I remember is from the NASA. So that data set is a very comprehensive data set related to these batteries. So if you search that about the NASA public data set, battery data set, NASA public battery data set, something like that. If you search for these keywords, then you will see that there is some data sets that are available, and they are related to batteries, and that can be used to basically people are using those data sets to implement AI and check the performance of the batteries. So this is a yes for this first question. If you have any other questions, so you can either turn on your mic or you can also type in the chat, and I will be happy to answer those questions. Further success rates in developing countries like Pakistan, apart from the technologies uses we face knowledge barrier and funding. Mm, I think knowledge barrier should not be a problem anywhere in the world now, because we have AI tools like ChatGPT and various other tools, so we can get the knowledge about what we want at any stage now. So we are just one message away. We can type a message in ChatGPT or some other AI tool, and we can get the knowledge about the topic. Funding is an issue. So to overcome this issue, what I recommend my students is that try to collaborate with the international people. So there are a lot of professors in the world that have the funding, but they don't have the, you can say, the right people to work in their labs. So they are continuously looking for new students or very passionate researchers that can basically help them in their different projects. So I think if you try to find out the professors related to your field, so you will be at one stage you will be able to find some professors that are looking to collaborate, and they are open to basically providing you the guidance and whatever things you require to perform the research. So they will be happy to basically collaborate with you. So try to get connected with those professors, and whenever they require some uh, help, so you can basically help them. Even if you cannot go abroad, so you can still do online work and you can still contribute to uh, your research interests. Oh, sir, they are reliable with high risks as well. Oh, sorry, I didn't get this. Can you please elaborate this one? They are reliable with high risk as well, so I couldn't understand the question. So briefly, if someone wants to connect with me, so on LinkedIn, you guys can find me using this ID, M Muzammil Azad. So if you are interested in collaborating with me or want to discuss anything, want me to be your mentor or want to collaborate in something, so you guys can connect with me. I will be happy to respond, and we can basically connect and try to do something together. Okay, so you are mentioning about the reliability of ChatGPT. So yes, ChatGPT is not 100% reliable. When you try to type something on ChatGPT, so at the bottom you will see a notification that don't rely on ChatGPT because it is not 100% accurate. So it is true that it is not reliable but for the basic information, like the things that are well developed. So for those things, the ChatGPT can be reliable. For something new or some new research topic, so it doesn't have information to train itself. So we cannot rely 100% on ChatGPT, but we can get some basic information, and then using that basic information, we can do more research and try to read more research articles rather than basically relying 100% on ChatGPT. So I use ChatGPT a lot, but I don't rely on it 100%. I just get the idea and then I explore that idea further by myself. So once I get the idea, I then explore the Google Scholar. I try to identify the recent research articles or review articles, and then I understand those topics from those research articles. So ChatGPT is good for generating some idea, but after that, I think we should close the ChatGPT tab and we try to read and understand from the original research papers. Yeah, so it has limited yeah, so it has some limitations in different regions of the world. It's true. So I cannot tell the exact tool for researchers and scientists. Recently, I came up with a tool that is related to Google Scholar. So it is, I think, Scholar Labs or something. So it is more related to the researchers. So maybe I think I didn't explore it myself too much, but I think because it is related to Google Scholar, so it will be more authentic for researchers and scientists. So if you guys want to check, so I think it's worth trying. And I didn't try it myself much, but I hope that it is much better and accurate than the other AI tools because it is getting directly information from the Google Scholar. Chipcom.app for assignment camera. Okay, so I am not sure about all of these tools, but I think based on the experience of each individual, these tools vary. So it's up to you guys that based on your research interest or what are you currently trying to achieve, you identify the best tool for that and try to work using that tool. But again, use these AI tools just as a tool. Don't copy paste things from it because it is, again, I'm mentioning it is not 100% authentic. There are a lot of errors that are produced when we use the AI directly and we don't think about the topic and we just copy paste things from there.
Okay, thank you so